Here in this task, we will predict using supervised learning machine. The actual problem is we will predict the score if the student studies for 9.25 hours per day. So we done this project in Google Colab. So first of all, we will import a drive where we actually upload our data set. Then we will import libraries, necessary libraries like NumPy, Pandas, Matplotlib, SPLT, Seaborn, and different libraries that is used for calculations and for plotting. Then secondly, in this line, we will actually import our dataset in the variable df. In the next line, df.head, we will actually print our 5 rows of our data. So we will see our data is looks like this. This is an index or a serial number, and we have a column hours and scores, 2 columns, and we have these data. Then we will explore our data more. Then df.column, it will tell us how many columns we have. We have a hours and scores, 2 columns, and the data type is object. Nextly, we will find the data types of our columns. Then horse the data type of horse is float 64 and the scores is int 64. Then we will get more information about our data df.info. This will actually tell us about this known null values. Like our data does not have any null value. So we will df.describe. In next line we use df.describe. It will calculate count, mean, std, mean 25%, 50%, 75%, and max. Then we will find correlation. Here is the output. Then we will check if there is null value. Then we will sum it and print it. But in the column horse there is no null value, and same as in scores there is no null value. For the distribution we will simply plot snc dot plot. In this plotting we will set a scores and density here, plot scores and density here, and same as here. In the next plotting, we use joint plot where x is equal to horse and y is equal to scores. Here is a scores and here is a horse, and this is a line that tells us our data. Now we will start a simple regression from here. So we will write a code for simple regression. This is a statement calculating the coefficient of simple linear regression equation where y is equals to b0 plus b1 dot x. b1 is a slope and b0 is an intercept. We use this code to calculate the b1. b1 is actually our slope and b0 is our intercept. So we find b1 and b0, our slope and intercept. In the next step we will make predictions. We make a column named predicted score. Here we add b0, this is actually our slope, plus b1. b1 is what? b1 is our intercept. Sorry, b0 is our intercept and b1 is our slope, and we will multiply this with the columns of holes, and we will find the predicted score. When we print is head, like when we print head, it will output the first 5 rows of our data set. So here is column added and we see the predicted score. In the next step we actually plot a scatter plot. We scatter plot and check our data, predicted score, and the horse, between the predicted scores and horse. Then we will use b0. b0 is actually for our intercept and b1 is for slope. and multiply by 9.25. Why we will do this? Because in our problem statement we actually find 9.25 horse, so we use we use this one, and the actual value is 92.90. So next step, we find root mean square. Root mean square, we use a formula of root mean square, and then we find this. And there is a OLS model. We find this OLS model, and in this step, model is equal to smf dot ols scores and horse. We find the OLS model of horse and score. We can observe the predicted value of odd 9.25 horse is around 92. Here, 92 is our predicted value. For additional conclusion, we add cutoff value of 40, like greater than 40 is passed. We say greater than 40 is passed. Then we add this condition and this column added. When we run this, there is greater than 40 is passed, and here it is true, and less than 40 is actually false. Here is the printed values. We In this step we plot the given result true and false. We have a greater values of trues instead of false, like we have a greater number of passed students and less number of false students, failed students. We actually here apply a feature engineering. Then this is the main step where we split the data in test and train. The training data is 20%. And here we train the Canon model, then we check the accuracy of Canon model, and in the last step we check the prediction of our outcomes. First we give the value 9.25 to our Canon model, it gave us true. Then we give 14, it give us true, and then in the last step we give it 3, it's print false. So this is our first project where we find the solution of our problem statement. Thank you.